So here are some examples, like the questions in 7.2, solving systems of equations. So the first thing I'm going to do is show you some 2x2 systems. That means 2 equations and 2 variables. And from there, we'll go to a 3x3 system, which is 3 equations and 3 variables. And this is a review, and this is Math 112. So I think it's best if we review the 2x2s first. So here are my 2 equations. 2x plus 3y is negative 11, and 5x minus 3y is 4. Well, we are allowed to add equations together. So when I add these together, look what happens to the y's. They cancel out because they have coefficients that are opposites. Negative 3 and a positive 3 is a 0. And when I add this side, I get negative 7. I divide by 7, and now I know the value of x is negative 1. So I added first to eliminate one of the variables, and now I'm going to substitute into either equation. I'm just going to choose the first one, that negative 1 that I got for x. So I get 2 times negative 1, because it's 2x, plus 3y equals negative 11. That's negative 2 plus 3y is negative 11. And now I'm just going to solve this like any regular equation. And I get 3y is negative 9 divided by 3. Y is negative 3. Now the last thing I want to do is I want to write an ordered pair for my answer, but you might also want to check the point in both equations to make sure that that's the correct answer. So you would just substitute it in. You would say 2 times negative 1 plus 3 times negative 3, negative 11, negative 2 plus negative 9 is negative 11. Well, that works there, but it has to work in both. So 5 times negative 1 minus 3 times negative 3 is supposed to be a 4. Negative 5 plus 9 is 4, and it also works there. So it's in your best interest if you double check it in all the equations, okay? And then we always write an ordered pair, of course, x, y. And if they give you different variables, which sometimes they do, a, b, they may use a and b, or W and Z, just put them in alphabetical order when you put them in the ordered pair. All right, here's another one. Now, in this case, 4x plus y equals 6 and 2x minus 3y equals negative 4. If I add these together, it doesn't really do me any good, because I get 6x minus 2y is 2. And that's fine, except it doesn't do me any good because I still have an x and a y. So instead of that, what I want to do is I want to multiply one or both equations so that I have opposites like I did in this first one, where I had the positive 3 and the negative 3, which canceled out. So I have a couple of options. If I multiply the bottom one by negative 2, my x's would cancel out. Or if I multiply the top one by 3, my y's would cancel out. So what I'm going to do, and just to keep up with what I'm doing here, and so I can tell what you're doing, is just draw an arrow and write on top what it is that you're doing. Okay, so what I'm doing is I'm multiplying that first equation by 3, and that gives me a 12x and a plus 3y equals 18. Now, you're allowed to multiply or divide as long as you multiply all terms of the equation by the same number and it's not a 0. So this one, I am not going to change. It's going to stay at 2x minus 3y equals negative 4. And now I'm ready to add because, look, once again, I have opposites here. and they will cancel out, and I end up with 14x equals 14, divided by 14, divided by 14, x equals 1. Then I'll use substitution. Doesn't matter which equation, I'll just do the first one. 4x is 1, plus y equals 6. 4 plus y equals 6. Subtract 4 from both sides, y equals 2. And just to be sure, 4 times 1 plus 2 should be 6. 4 plus 2 equals 6 is correct. 2 times 1 minus 3 times 2 should be negative 4. 2 minus 6 equals negative 4. That is also correct. So my ordered pair solution is 1, 2. Now in this example 3, I'm going to have to multiply both equations to get something to eliminate. It's totally your choice. Do you want the x's to eliminate or the y's? It doesn't matter. I'll just get rid of the x's this time. I look at these two numbers, and I see I have a 5 and a 2, and they'll both go into 10. So I'm going to multiply the top one by 2 to give me a 10x, and 8y equals 6. And I'm going to multiply the bottom one by negative 5 to give me a negative 10x, a negative 15y equals negative 20. Because I now have a negative 10 and a positive 10, those will cancel out, and I'll be left with a negative 7y equals negative 14 divided by negative 7, y equals 2. Then I'll use substitution, doesn't matter which one, so I'll do it in the first one. So 5x, this time I have to substitute the y, so 4 times 2 is 3. 5x plus 8 equals 3. Subtract 8 from both sides. 5x equals negative 5. Divide by 5, divide by 5. X equals negative 1. So I have x is negative 1, y is 2. Double check my answer. 5 times negative 1 plus 4 times 2 is supposed to be 3. Negative 5 plus 8 equals 3 is correct. 2 times negative 1 plus 3 times 2 should come out to 4. Negative 2 plus 6 is 4. So my ordered pair is negative 1, 2. That is the solution to my system. So now let's look at some 3x3, a couple of 3x3 examples. Now this is going to be slightly different because you've got 3 equations and 3 unknowns, and so what you're going to have to do is reduce this down to a 2x2, and then we'll solve it like we just did, and then we'll use substitution to find the third unknown. So what you want to do is you want to select any of the 3 equations to be what I call the eliminator. Okay, remember this is the elimination method. So I'm going to use that equation with both of these, number 1 and number 2. So to track what you're doing, and so I can help you and follow it, label one of them with an E and the other one with a 1 and a 2. It's your choice, except typically you want to choose your eliminator to have a coefficient of 1 in one of the equations because it makes it easy to eliminate. And you'll see as I go through here. So the first thing I do is I take E with 1. Okay? E is x plus y plus 5z equals 16. And 1 is x plus y plus 3z equals 10. And I need to decide which variable I'm going to eliminate in number 1 because I have to do the same thing in number 2. So let's say that we're going to eliminate y. Okay, it's your choice, but you need to make sure you do the same one in both, so I usually write it down. So what I'm going to do is I'm going to multiply this one by -1 because I want to get a 1 here, a -1 there, and a 1 there. So I have -x, -y, -5z is -16. And then I'm doing nothing to the bottom one, so I just write it over here underneath. And then I add them together, and look how lucky I am because the x and the y got eliminated, and I'm just left with a -2z equals -6, so z is 3. So I already know that z is 3, even though sometimes you'll still have an equation with 2 variables there, and you'll see that in the next example. So now I know z is 3. So I could do e with 2, and I'll go ahead and do it that way. Another option is to substitute the z into any two of these and just solve it as a 2 by 2. But I'll go ahead and do it pretending that I didn't get just a z is 3, and you'll see again in the next example why I'm doing this. So my eliminator is the original first equation. And now I'm going to work with equation number 2, x plus 7y minus 4z equals -29. Now remember, I want to eliminate y in this one as well. So I need to have a -7y right here and a 7y right there. So I'm going to multiply this one by -7. -7x minus 7y minus 35z equals 16 times 7, that's a -112. The bottom one, I'm not going to change, so I'll just write it x plus 7y minus 4z equals -29. Add them together, -6x, the y's cancel out, minus 39z equals, what's that going to be? -141. Okay. Now, because I know that z is 3, I can now put it here in this equation. So -6x minus 39 times 3 equals -141. And so let's see, 39 times 3, 117. So -6x minus 117 equals -141. I'm going to add 117 to both sides. -6x equals -24, and it's going to be negative because I've got more negatives than positives. Divide by -6, divide by -6, x equals 4. So I have an x is 4, a z is 3, and the last thing I'm going to do is I'm going to find the y in either of the originals, any of the originals. I'll just go with the eliminator, okay? So it's x plus y plus 5z is 16. So x we got was 4. Y we don't know. 5 times 3 has to be 16. So that's 4 plus y plus 15 is 16. That's y plus 19 is 16. Subtract 19, y is -3. So what you want to do is you want to check those, and when they check, you write an ordered triple, x y, z, which would be 4, -3, and 3. But do make sure that you actually go through the process to check them, all three, in all three of these equations to make sure that it works in all three. All right, so let's do one more of these, and this time you'll see why I need to eliminate the same variable in both. And unfortunately, I'm going to have to multiply both equations each time. So again, it doesn't matter what you pick for your E. Your eliminator, I'll pick it to be the first one. So this is going to be E. This is going to be 1. This is going to be 2. So I take my eliminator. 5x plus 2y minus 5z is -9. I'm going to combine that with equation 1, 2x minus 4y plus 2z equals 14. Now I can decide which variable I want to eliminate here, just keeping in mind I have to do the same one when I do equation E with equation 2. And I'm just thinking this is going to be easiest because all I'll have to do is multiply the first one by a 2. So multiply that by 2, 10x plus 4y minus 10z is -18. This one I don't need to multiply because it's 2x and there's a minus 4y, so those have opposite coefficients. Plus 2z is 14. Combine these two by adding them. 12x. The y's cancel out. Minus 8z is -4. So look, I now have an equation that has two variables. So I'm just going to leave it there for now and take equation E with number 2. So 5x plus 2y minus 5z is -9, and 6x minus 5y plus 6c is 28. Now remember, I have to get rid of the same variable, so I've got to get rid of the y's, so I'm going to have to multiply both of them. 2 and 5 both go into 10, so this one by 5 and this one by 2. I'll get 25x plus 10y minus 25z is -45. And let's see, by 2 will be a 12x, a minus 10y, a plus 12z, and a 56. Now be careful, you have to make sure you multiply all of them and you have to watch your signs. So this time, the 10s are going to cancel out, the y's, right? So the 10 and the -10 of the y will cancel out. So 37x minus 13z equals 56 minus 45 is 11. Now I have another equation, and it only has an x and a z. And so it's going to be messy, but now I've got to solve. 12x minus 8z equals -4, with 37x minus 13z equals 11. And so since these numbers are pretty big, I'm going to grab a calculator. All right, and it doesn't matter, it's my choice as to which one I will eliminate. I'm going to pick the z's, okay? I'm going to get rid of the z. So I need to multiply 8 times 13. They'll both go into, let's see, 8 times 13 is 104. So I'm going to multiply the first one by 13, okay? So this is times 13. And I get 12 times 13 is 156x. Okay. And then 13 times negative 8, that's the 104. So it's going to be a minus 104z. And then 13 times negative 4, that's a negative 52. I need to multiply the bottom one by a negative 8, because watch what happens if I do that. 37 times negative 8 is negative 296x. Numbers are getting big, which is why I have my calculator. A negative 13 times a negative 8 gives me a positive 104z. That's why I needed to do the negative times the negative to get the positive there, so that these will cancel out when I add them. And then let's see, I've got to multiply 11 times negative 8 is negative 88. All right, so now, using my calculator, negative 296 plus 156, negative 140 x, z's are eliminated, equals negative 52 plus negative 88 is negative 140, divide by negative 140, divide by negative 140. I now know that x equals positive 1. So I only know the x. However, I have two equations that just have an x and a z. So I'll use the first one. That is the 12x minus 8z is negative 4. And I'll put in an x is 1. So 12 times 1 minus 8z is negative 4. That's 12 minus 8z, negative 4. Subtract a 12 from both sides. Negative 8z is negative 16. Divide by negative 8. Z is positive 2. So now I know my z value is 2. And now that I know x and z, I can take any of these original equations and I can put in the x and the z, and I can find my y. So I'll use the eliminator, so it doesn't matter which one. So I'll take e again, and it's 5x plus 2y minus 5z equals negative 9. And I'll do 5 times 1 plus 2 times y minus 5 times 2 equals negative 9. It's 5 plus 2y minus 10 is negative 9. It's 2y minus 5 is negative 9. Add 5 to both sides. 2y is negative 4. And if 2y is negative 4, I divide by 2, and y is negative 2. So there is my y value. So the answer would be order triple, x is 1, y is negative 2, and z is 2. And again, it's best if you actually check these, and you need to check it in all three. So you would put that same order triple, 1, negative 2, and 2, into all three of these. So 1, negative 2, and 2. So you want to check those to make sure that they work in all three, and then your final answer is this order triple. So let me do just one more of those, because it's a pretty long process. It's a lot of arithmetic, so you have to be really careful to not make an arithmetic mistake. So let's see. Let's do, I gotta find one that I know will work out nicely. I don't want to introduce any fractions all of a sudden. Okay, here's a good one. Now this one is in a little different form, so here we go. We've got 5 times 4x plus y plus 3z equals 19. And then we have 4 times x minus 5y plus 2z equals 7. And then we've got 4 negative 3 plus 4x equals negative 5 times z minus 5y. Well, we've got to get this into 3 equations with x, y, and z in order on the left. So I'll just call this one E again. We'll use it as the eliminator, this one 1 and this one 2. So I need to work on E first. That's going to be 5 times 4, 20x plus 5y plus 3z equals 19. So that's our right format. Number 1, I've got a 4x, a minus 20y, a plus 8z equals 7. And then for number 2, I've got negative 12 plus 16x equals negative 5z plus 25y. So these two are in the correct format, but I need to do more cleanup on the second one. So I'm going to add a 12 because the number should be on the right-hand side. That's going to give me 16x equals negative 5z plus 25y plus 12. I'm going to subtract a 25y. That's going to give me 16x minus 25y equals negative 5z. See, these canceled out. So that's going to be plus 12. And now I need to add the 5z to both sides. So this is 16x minus 25y plus 5z equals 12. So that's going to be my actual equation number 2. All right? So let's do E, 20x plus 5y plus 3z equals 19, with number 1, 4x minus 20y plus 8z equals 7. And I think I'm going to eliminate the y's. So I need to multiply the top one by 4, 80x plus 20y plus 12z is 19 times 4, which is 76. And then, since I've already got a minus 20, I just need to copy equation number 1, 4x minus 20y plus 8z equals 7. I can add these together to eliminate the y's. 84x plus 20z equals 83. Let me write that better. 84x plus 20z equals 83. And so this is going to be my first equation in x and z. Now I need another one in x and z. So eliminator with number 2. So my eliminator is 20x plus 5y plus 3z is 19. And equation number 2, after all that work, was 16x minus 25y plus 5z equals 12. So now I see if I multiply this one by 5, I'm going to get 25 and a negative 25. So this one's going to stay the same. 100x plus 25y plus 15z is 19 times 5, which is 95. And then 16x minus 25y plus 5z equals 12. 116x plus 20z equals 107. So that's my second equation. Now take a look. This is going to work out nice because look, this is a 20 and this is a 20. So if one of those was a negative 20, we could add them together to get our x value. So let me copy these and take it to a new page. Okay, so I've got this 8x plus 20z and this 116x plus 20z. All right, so 84x plus 20z is 83, and 116x plus 20z is 107. I'll multiply this one by negative 1, negative 84x, negative 20z, negative 83. And this one is 116x plus 20z equals 107. Add them together, negative 84 plus 116 is 32x. The z's get eliminated, and 107, or negative 83 plus 107 is 24. And it looks like this one has a fraction for the answer. 32, x is 24 over 32. I just reduce it on my calculator. 24, fraction key 32, and I get a 3/4. So x is 3/4. Now, if x is 3/4, I can go back to my original equations and put in an x is 3/4. So remember what I have here. I have the eliminator, and that's fine. I've got 20x plus 5y plus 3z is 19. And I've got 4x minus 20y plus 8z is 7. And now I've figured out that, that x is 3/4. So it's not going to be that hard. Fractions do pop up from time to time, but this one's not that messy. So look, instead of the x here and here, I've got to put a 3/4. So that's 20 times 3/4 plus 5y plus 3z is 19. And 4 times 3/4 minus 20y plus 8z is 7. Now I could have put it into one of these equations, excuse me, as well. I could have put x is 3/4 in either one of those. And that might have been more efficient, because if I do that, and so now that I know x is 3/4, and it's a fraction, but that's okay. It's going to work out okay here, because look, 84 times x, it's right here, Well, x is now 3/4. So I'm going to put a 3/4 here. Plus 20z equals 83. Well, 84 times 3/4 is, I'm going to do, let's see, 4 into 84. I'll do it the long way. 21 times 3, that's going to be 63. Plus 20z is 83. Subtract 63. 20z is 20 divided by 20, and z is 1. Z is 1. And now that I know x is 3/4 and z is 1, I can go back and I can find y, and I'll go back and find y, and I'll do that with equation, that's the E, the one that we transformed and cleaned up, 20x plus 5y plus 3z equals 19. And I'm going to put in all that I know. So I know 20 times 3/4 plus 5 times y, 3 times 1 equals 19. So I put the 3/4 in for the x and the 1 in for the z. So there it is right there. So I'm going to get, you can do this on your calculator, but 4 goes into 20. 5 times 3 is 15 plus 5y plus 3 is 19. 5y plus 18 equals 19. Subtract 18, 5y equals 1. So y is a fraction also 1/5. So 3/4, 1/5, and 1. Now I want to check this in all three of the original equations, okay? Because this is kind of a weird looking answer, and you want to make sure that you actually, check your answers, especially on tests, to make sure that they're correct. So I'm going to take the original, and I'm going to take my ordered triple. And I'm going to check it in all three. And if it doesn't balance out in all three, then I know I have a problem. So we called this one E, this one 1, this one 2. So I'm just going to keep calling them that. 4 times 3/4 plus 1/5 plus 3 times 1 is supposed to be 19. So that's 5 times 3 plus 1/5 plus 3 is supposed to be 19. So I'm going to go ahead and distribute. It's going to be easier if I do that. Use your calculator if you have to. 15 plus 1, because 5 times 1/5 is 1, plus 3 equals 19. 16 plus 3 is 19. It works in equation 1. I'm sorry, in equation E. Now in equation 1, it's going to be 4. And let's see, we got 3/4 minus 5 times 1/5 plus 2 times 1. Supposed to come out to 7. So that's going to be 4 times 3/4 minus 1 plus 2 equals 7. So that's going to be 4 times 3/4 minus 4 times 1 plus 4 times 2 should be 7. So that's going to be 3 minus 4 plus 8 equals 7. Negative 1 plus 8 equals 7. That is true. So as long as it checks out in equation 2, then we're in great shape. So 4, negative 3 plus 4x equals negative 5z minus 5y. And I'm going to put in 3/4 for the x. So negative 3 plus 4 times 3/4 equals negative 5. Z is 1 minus 5 times 1/5. So that's 4 times negative 3 plus 3, because look, 4 and 4 cancels out, equals negative 5 times 1 minus 1. That's 4 times 0 equals negative 5 times 0. That's 0 equals 0, and that is true. So that means that I am correct, that the answer is x is 3/4, y is 1/5, and z equals 1.